So, here's 4.3. This is the last lesson before your test. That's probably going to be next Tuesday or Wednesday. And it's all about congruent triangles. Okay? So when we're talking about the word congruent, it means everything's the same. Same size, same shape, everything. They can be rotated differently, but they still have the same size and shape. So you see these are the same size and shape. They're just rotated. However, these are the same shape, but they're not the same size. Do you see how it gets smaller? So these are not congruent. They might be similar, but they're not the exact same. Okay, so in order to determine if two triangles are congruent, everything about them has to be the same. So for example, angle A right here. How many rainbows does angle A have? 2. So in order to say that it's congruent to an angle over here, this angle has to have 2 rainbows. So angle A is congruent to angle H because they both have 2. Angle B has how many rainbows? So it's congruent to angle J. Angle C has how many rainbows? So it's congruent to angle K. Alright, so that's not bad. However, when you're writing the corresponding sides, okay, so we're talking about corresponding parts. That means a corresponding is the other part on the other triangle in the same position. Okay, so corresponding sides, they're starting with A, B. That means they're going on the line that has 1 dash. But you have to be very particular about the order. So they went from A to B. So that's 2 rainbows to 1. So when you're saying AB is congruent to the 1 dash over here, you can't say JH. Why? It's going 1 to 2. If I started AB 2 to 1, I have to go 2 to 1. That's why AB 2 to 1 is congruent to HJ 2 to 1. BC goes from 1 to what? 1 to 3. So over here I have to start from 1, which is J, and go to 3. Okay, lastly, the one with 3 dashes, I know it's congruent to this one because they both have 3 dashes. But the order is so important. A to C, which is 2 to 3, is congruent to HK because you have to go 2 to 3. So we had to go through 6 steps just to prove 2 triangles are congruent. So this is your final, your final statement. It's called your congruent statement. It's like your main answer. But look at the order that they put it in. A, B, C. How many rainbows does A have?
2.
How many does B have?
1.
C.
3.
So they went in the order 2, 1, 3. So look over here. How many does H have? J? K? They're in the same order. You have to be in the same order. Okay, now here's another valid statement. How many rainbows does B have?
1.
C?
3.
A?
2.
J? Huh?
1.
K?
3.
H?
2.
So you see, these are the same triangles. But as long as they're in order, it doesn't matter where you start, as long as they're in order. So if you go 1, 3, 2, you have to go 1, 3, 2. But over here, ABC, which is 2, 1, 3, I got that from up here. HKJ is 2, 3, 1. That's why this is not a valid statement. Okay? So, it's very tedious because you have to prove 1, 2, 3, 4, 5, 6 things before you can say these are congruent. So let's practice. Let's start with number 1. You have to show that the polygon, that every part is congruent, and then write a congruent statement. So you have to show all three angles, all three sides, and then write a congruent statement. So, let's start with angle A. What's angle A congruent to? Angle J. What's angle B congruent to? Because they both have two rainbows. Angle C is congruent to angle L. So those are just all three of the angles. Now we have to prove the sides. Okay, so it doesn't matter where we start. We just have to be consistent. I always go in order. I like to go 1 dash, 2 dash, 3 dash. So, AB is congruent to what? Good. Because you went from 1 to 2, you have to go from 1 to 2 again. So, AB is congruent to JK. Alright, I'm going to go BC. BC is congruent to, okay, what? L. Good. And then, side 3, AC is congruent to what? JL. Good. Check. 1, 2, 3, 4, 5, 6. I can make my final congruent statement. Okay? So, what do y'all want to call this first triangle? Thank you. Okay, you want to call it ABC? Okay, so now triangle ABC is congruent to triangle. We went 1, 2, 3. So now we have to go 1, 2, 3. So that's triangle JKL. Are y'all following me? Okay. We're not going to finish all 6 of these because that's very repetitive. But let's do number 2. Okay, so here's the thing about number 2. You can't just throw out angles. Here's the reason why. B, if you just say angle B, I don't know which one of these angles you're talking about. If you just say C, I don't know which one of these angles you're talking about. The only angle I know for sure what you're talking about is if you say angle A and D. Okay, so let's start our 6. Let's start our 6 different parts. Sorry, I write too big. I have to get more paper. Okay, so I can say angle A is congruent to what angle? Huh? Angle D. Okay, so that's one rainbow. Let's look at just this angle that has 2 rainbows. How do I name this angle without just saying angle B? ABC. Yep. Angle ABC is congruent to angle. Okay, so we went 1, 2, 3. So now when I cover this triangle, I have to go in the same order. So this angle right here with 2 rainbows is congruent to this one over here with 2 rainbows. But how do I name it? DCB. Do y'all see why every chapter in geometry is so important? It literally always builds on each other. Okay, now we have to prove the third one. Angle ACB is congruent to what? DBC. Yep. Okay, so we've proven all 3 angles. Now we have to prove the sides. So, which one do you want to do first? You want to do AB, so you want to go with 2 first? You don't want to be a person of order? Okay, I'm going to do AC. Sorry. AC. So I went from 1 to 3. So AC is congruent to what? DB. AC has 1 dash, so does this one, but I went from 1 to 3, so I have to go from 1 to 3. Okay, now let's do a side AB. is congruent to what side? DC. Good. Okay. Do you remember in 2.6 when we were proving algebraic proofs? And we learned, or in any proofs actually, and we learned the property reflexive. Do you remember the reflexive property? It means whatever, like say we say KL. Well, the reflexive property says that KL is congruent to KL. The same thing, right? We still have to prove this third side. So what do I say? Well, if I go BC, side BC is congruent to what side? BC. Because of the reflexive property. We'll go a little bit more in depth in that later. Huh? Well, that's not the reflexive property, though.
But you're going in the same order.
Yes, because these are the same angles. For example, if three rainbows is, let's just say 60 degrees, right? So this also over here has to be 60. Let's say two rainbows is 30. So this is, oh, that's bad, because let's say 40. Okay? Well, this one right here is also 40. So together, these angles are the exact same thing.
But you're not going in order of how many arcs they have.
But you have to think of them as whole angles. I'm not talking about angle CBD. I'm talking about this whole angle. Okay? So I'm thinking about these angles as a whole. So if I am kind of like ignoring the 2 and the 3, I just have to prove that these sides are the same. And I have to use the reflexive property, which means both sides are the same. You could also, so you could do CB is congruent to CB.
At this time, we need thespian and French clubs to the...
So let's write our overall statement.
All the sponsors, please.
Guys, this is going to take practice, okay? It's just going to take practice. So,
And
that was just for an example.
Thank you.
Let's write our congruent statement. Triangle. What order do you want to go in the first one?
ABC.
Okay. Triangle ABC is congruent to triangle what?
DCB.
D. So y'all went A, B, C. D, C. Yep. D, C, B. Okay. Let's do one more. Do 5. I want you to try 5. Okay, so you should have angle D is congruent to angle A is congruent to D. Okay, then you could have angle ABC is congruent to angle DCB. Then your third angle would be angle ACB is congruent to angle DBC. Okay, so those are your 3 angles. So now do your 3 sides. So side AB is congruent to side DC. Side AC is congruent to side DB. And then your last side, doesn't the reflexive property have an X in it? Okay, so you're going to have to start doing proofs, and you're going to have to use the reflexive property to say why you can say that BC is congruent to BC. So instead of putting 3 dashes on this middle one, if it's proven by reflexive, I always put an X. For two things. One, to tell me that they're the same. Two, to tell me that it's used by reflexive. Okay, so X. So BC is congruent to BC. Or if you want to say CB is congruent to CB, you can. So I have 3 angles, 3 sides. So now I can write my congruent statement. Triangle ABC is congruent to triangle DCB. Okay, let's go to the back. I know we didn't finish, but let's go ahead and go to the back. So, when you know you're told 2 triangles are congruent, remember how order was so important when we were writing it? Well, it's so important for this reason. If A is the first angle, then it's congruent to the first angle right here. So A, I'm going to put 1 circle around A because there's not much room to put a rainbow. A is congruent to what angle over here? D. B is congruent to what angle? Okay, so I'm going to put a square and then square around E. And then C is last. So C is congruent to F. Okay, so that told us all of our angles. Now think about your sides. If A is right beside B, so the first 2, AB, I'm going to put 1 dash on line AB. It's congruent to the first 2 over here, which is DE. So AB is congruent to DE. So if I have 1 line on AB, I can write 1 line on DE, or 1 dash. Okay, next we have BC, the last 2. Well, BC is congruent to what? EF. So I'm going to put 2 on BC and 2 on EF. And then A is first and C is last. So AC is congruent to DF. So now your task is to solve for X and Y. Well, right here, X and Y are in the same equation. So I don't want to find this yet because I don't know either of them. So here's Y by itself. So we should probably find Y first. Well, what's angle D congruent to? A. D is congruent to A. So to solve for Y, I'm going to set 2Y minus 5 equal to 65. So solve for Y. Well, I need to get 5 to the other side, right? So 2Y is equal to 70, and Y is equal to 35. So now I have Y. We have to find X. Okay, well, X is over here on EF. Well, EF is congruent to this one with 2 dashes. So set these 2 equal to each other. 2X plus Y equals 90.6. Well, what do we need to plug in? 35. So 2x plus 35 equals 90.6. I got x is equal to 27.8. Did y'all follow me? The hardest or the most important part is making sure you know how to read this congruent statement. We're going to skip 9 and 10, but because 9 and 10 are the same ones that are on your homework. So just know that it works the same way with a polygon of 4 sides.
So we just don't have
So AB is congruent to PQ. Okay, it works the same way. So let's get to the bottom. This theorem is very, very important. You're going to use it a lot. What it means, draw 2 triangles. Sorry, mine are really bad triangles. Okay, A, B, C, D, E, F. If I am given, I'm not proving, they've told me this. Angle A is congruent to angle D. Okay, so they told me A is congruent to D. And they told me B is congruent to E. So I know that 2 angles are the same. A is congruent to D, B is congruent to E. The third angle theorem says if 2 angles are congruent to 2 angles of a second triangle, then by this theorem, you can assume, you can say, well, if these 2 are congruent, then angle C has to be congruent to angle F. Does that make sense? Because we know these 2 are the same, A to D and B to E. Well, third angle theorem says if you know 2, you can say, and it is true, that the third one is the same. Alright, so let's do this proof. It's really not as bad as the proofs in Chapter 2. Because, and the reason it's not so bad is because we have the same goal every time. Okay? Our goal every single time is to prove 3 angles are congruent and what? 3 what? Sides. Every time. You're not done until you've shown 3 angles are congruent and 3 sides are congruent. Okay, so I didn't make first period, so I'm not going to make y'all. I just let them put little quotes here so you didn't have to write all that. But what you do need to do, and let's do it together, let's go through and identify everything they've given us. Because if they've given us, then we don't have to prove it, right? If they tell us it's true, I don't have to do it. Okay, so A is congruent to C. So 1 rainbow, 1 rainbow. D is congruent to B. 2 rainbows, 2 rainbows. Line AD is congruent to CB. So 1 dash, 1 dash. AE is congruent to CE. 2 dash, 2 dash. So that's what they've given us. They've given us 2 angles and 2 sides. So what do we have left to prove? How many angles, how many sides? 1 and 1. Now, they told us AC bisects BD. AC bisects BD. What does bisect mean? It cuts it in half. So they've told us that, but we have to know AC bisecting BD means that this is congruent to this. So that's our first thing that we have to show. So on to DE is congruent. What order do I put this in? DE is congruent to what? BE. Good. Well, what can our reasoning be? Definition of bisector. That's what it means. If it's a bisector, then it sets them congruent.
Is that
DE, yep. Okay, we have one more thing. So now we've officially covered all 3 sides. But what about the one angle that's missing? Do you see it? This one? There's actually two ways I can prove that these angles are congruent. Do you know which two? What'd you say? Vertical or what? Third angle theorem. To me, this looks like it'd be best proven by vertical. Because, I mean, it is vertical. So, we can say, step 3. Go in the same order. Angle AED, AED is congruent to angle CEB. Yep. And I'm going to put vertical angles are congruent / third angle theorem. Because technically you could use both. Okay, so have we proven all three sides? Have we proven all three angles? Okay, so in conclusion, we're done. So they've put right here, prove. So let's write exactly what they have. Triangle AED is congruent to triangle CEB. But here's the new part. How do I say, well, I know because I proved all three angles and all three sides? There's a saying. Actually, there's a saying in a shortcut. You want to write the shortcut, I promise. The reason, and this is called this like in other high schools and geometry books in college, like everybody calls it the same thing. It's called CPCTC. I'm going to tell you what it means. CPCTC. What?
Is it corresponding parts congruent, triangles congruent?
Yes, you left off two words, but they're little words. It's corresponding, so you do not have to write this out every time. But write it out so you know what it means. You never know if it's going to be a bonus. Corresponding parts of congruent triangles are congruent. Wouldn't you rather write the shortcut? Congruent parts of congruent triangles are congruent. CPCTC. So, 3 C's, P in between, T in between. CPCTC. Alright, so you have a couple of things to finish between now and tomorrow. If you look at the back, I want you to complete 1 through 5. Now, number 5 is a proof. And they didn't draw you a picture, so I want to draw you one because I think it'll help since it's just our first day doing this. So here's your picture. Okay, so before you come back tomorrow, I need you to finish 1 through 5. And since we skipped our math workshops this morning, I need you to do 7, 8, 11, and 12 on your math workshop. Okay? So these 5, 7, 8, 11, and 12. You actually have about 15 minutes to work now.